Hi everyone, so let's do this question today. Majority element. And let's read the question. So given an array nums of size n, return the majority element. Okay. So isn't this question too easy? Could you solve a problem in linear time and O of one space? Yes, right? The majority element is the element that appears more than n by 2 times. You assume that the majority element always exists in the array. Okay, so I need to find a number that is, so it means that I need to find, so the question says in an array there are elements, and there will always be one element which will appear more than half, right? More than n by 2 times. So if there are 4 elements, then there will be one element that will occur 3 times. If there are 3 elements, then I think it will be 2. Yeah, more than n by 2 means 2, right? So 3 is 3, and here it will be 2 because 2 has occurred more than once. So I need to do it in linear time and constant space. So how can I do that then? How can I do that? Linear time, constant space, there is an array. Obviously the straightforward solution is to keep count of every numbers, right? And whichever number has occurred more than half, that is the, but I think that there is some trick here, because because it is said that because here they have said that it exists more than half, right? So I think there is trick here about, because it says more than half. Yeah. Okay, so more than half. So how will I know if some element is occurring more than half? If only one element occurs, right? More than half. Just by going through it once, just by looking at it once. So if this is 2, 2, four, 2, 3, just by looking at it once, how can I know that it has just occurred once? Just half times. I don't know. More than n by 2 times. So it means if n is equal to suppose 6, then it will occur more than 3 times, right? If n is equal to 7, then 7 by 2 is 3.5. Yeah, 7 by 2 is 3.5. So it will occur more than 3.5 times, which is 8 times, like which is greater than or equal to 4 times. So in any array, if suppose one suppose A, B, C, D, E, F, G, there are 7 numbers, right? So if some number occurs more than 4 times, then how will I know? because there might be some number that might occur just less than half, right? So 2 will occur 3 times and 1 occurs 4 times here. So if I am traversing through this array, how will I know if the answer is 1 or 2, right? Because when I'm traversing this, when I'm just traversing, looking at this, okay, so 1 2 1, if I do not keep track of the count, then how will I know? And if I keep track of the count, then I will have to create an S map, isn't it? Or maybe what I can do is, yeah, one thing I can do, I can just keep track of 2 numbers only, maximum and second maximum. Okay, so I can just keep track of, yeah, one number only. So I can just keep track of one number, and if I find any other number which occurs greater, then I'll just say that, okay, that is the maximum, Yeah, I think this is it. This is the way. Yeah, there is no any other way otherwise, because I will have to keep track of 2 numbers always, maximum, second max. Because if I keep track of all numbers, then it will be O of n space, and I need to keep track of 2 numbers always. I cannot just keep track of one number, right? Because if I just keep track of one number, then I might lose the biggest one. Here, see. So if I just keep track of one, then 2 also might be the case, right? So but if I keep track of 2 numbers always, then yeah. So this is it. I think this is the answer. That's great that I thought about it. But I thought about it very slowly, very late. So anyway, let's go directly. So maximum number, um maximum occurrence number, and then second maximum occurrence number. Okay, so there will be 2 numbers, and then while I'm going through it, actually what I can do is occurrence map for maximum and second maximum. Or what I can do is I can just do that only, actually. Maximum occurrence. So right now it is 0 0, and then it will be 0 0 in the beginning. So 0 is the number, and this is the count. Okay, number and count. So norms I can go can be negative to 10 to the power 9, right? Okay, anyway, so let's start. So for let constant norm of numbers, So there is maximum and second max, right? So in the beginning, maximum can also be 1. So count is 1, right? And there is 2. 2's count is also 1. Suppose there is 1 again. Okay, so 1's count is 3. And second maximum. So I got a new number, right? Whenever I get a new number, my second maximum will be updated to 1. And then this number I got it again. So this will be 4. Suppose if I get a number 3 here, then yeah, if I get a number 3, then I have to update 2 and 3 both, right? Oh no, this is not the correct way, I think. Because see, until here I can see that okay, this is 1 1 1 and this is 2 and 3. So suppose if this is 1 2 and 3 in the beginning, then 1 1, then how will I know which one to keep track of? How will I know if I should keep track of 1 2's count or 3's count? Suppose there might be 2 to 2 2 2 2 at last, right? Or see, when I'm just traversing through here, then this number, this can go anywhere, any direction. So when I'm just looking at this 1 2 3 1 1 2 2, so this is 1 2 3 4 5 6 7 8 9. 9 by 2 is 4 5, right? So 1 2 3 4 5, so 2 is the answer here, right? And here the answer is 2 and here the answer is 3. But when I'm just looking at this array in the beginning, how will I know what is the count here? I think I should traverse it multiple times. Because if I just look at this one, I cannot just keep track of maximum and second maximum, right? Here you can see that 1 is a maximum, then 2 and 3 they are all equal, and then 1 1. So 1 is the maximum here. But how will I like, or yeah, like I said, right? What if there is 4 5 6? Then I will have to keep track of all those numbers. In an array, so it will increment the size of space will be more than 1. Yeah, space complexity is O of n. What? Yeah, linear time and O of 1 space. I need linear time and O of 1 space. This sorting will also not work because sorting is O of n log n. Oh, bit manipulation is the answer. No, bit manipulation also takes O of n log c. What is the answer then? Time complexity is undefinitive. Divide and conquer. Is this O of? No, this is also n log n. I'm happy that I looked at the editorial because looks like the answer is Boyer-Moore voting algorithm. You know, this is the solution that I was looking for, which is an algorithm, which obviously I'm a simple normal person and I'm not a mathematician who can form an algorithm in like 10 minutes. So yeah, sorting. I was thinking about sorting and everything, you know, but obviously that doesn't work. And bit manipulation, I need to study what bit manipulation or how bit manipulation works. Anyway, so let's see how this algorithm works. So if we add, because I'm interested to know this algorithm, and even if this is an algorithm, I'm interested to know how this algorithm works, because it would be really interesting to know how to solve this in linear time and constant space. If we add some way of counting instances of the majority element and instances of any other element is -1. Oh, summing them would make it obvious that the majority element is into the majority element. Interesting. What is it saying? It's interesting, but I do not understand. So if we add some way of counting instances of the majority element as +1, okay. So okay, 2 2 2 1 1 1 1 1, and instances of other elements -1. Then summing them would make it obvious that the majority element is indeed the majority element. What? What does this mean? Counting instances of the majority element as +1. Counting instances of the majority element as +1. I don't understand what this means. What does this counting instances of the majority element as +1 means? Does it mean I have to add +1 or what? Let's look at. So is look for a suffix sum of norms where 0 is the majority element in that index. To do this, we maintain a count which is incremented whenever we see an instance of a current candidate for majority element, and decremented whenever we see anything else. What? What? I'm streaming, yes. What are you saying, dude? We maintain a count which is incremented whether we see an instance of our current candidate for majority element, and decremented whenever we see anything else. Obviously, obviously we would want to do this, right? We want to do this, but how do we know if that is our majority element or not? Yeah, actually, I understood what this means, but yeah, actually, that makes sense. Because if it is a majority element, if it is, yeah, that's what I was saying, yes, right? So I was saying that there must be some way to utilize this condition that we are given, that it will be majority element, right? So like I wrote before, so if it is A B C D E F G, okay, and if it is a majority element, it means first four numbers will be majority elements, right? I mean first for any number will be majority element. Any number, like it can be in any order, this A can be in any order. So what I am saying is, if it is positive and if these are negative, then suppose if this is positive, right, and these are -1, then then negative, negative, negative. So if I just consider A as positive, okay, +1, then it will be 1 1 1 1 -1 -1 -1, right? um so the answer will be positive only. So what I'm trying to say is, I can just look at look I can just consider every number I can just consider, okay, A as positive first, and if the sum is the positive, then this will be answer. Or suppose if I consider E as the positive one, okay, then everything will be negative. So since half will be negative, the answer will always be negative. So that is the logic here that they are doing. But for this also we have to look at all the elements, right? We have to consider all the elements. Some this also some first consider this element as one, and first assume that this is one, and consider and replace this by positive one, and all other by negative, and then again assume another number, and then again assume another number, and then again assume another number. So will that not cause a lot of time? It will cause a lot of time, isn't it? One time complexity will be high, because for every number I need to do, suppose if there are like 1 2 3 4 unique numbers, then for all 4 unique numbers I have to do it, like it will be n times n, because for all n numbers I have to run it n times, right? So how are, so this is the intuition. So how are they optimizing this? To do this, we maintain a count which is incremental whenever count equals 0, we effectively force that, okay? It is not immediately obvious why we can get the prefixes of norms minus consider. So 7 at index 0 is selected to be the first candidate, right? First candidate for. So 7 is 7, and 7 is 0 is done as the candidate element. So if it fails, then we consider another element as the majority element. Suppose 5. Performs constant work exactly n times. So it performs n times. It performs this summation n times. And I was thinking that this summation will also take n time. But they are saying that this summation will take constant time. How? Interesting. So they are saying that this summation will take constant time. So we are doing it n times for all the possible candidates, right? So it will be n times. But this summation work, I thought that it will be 1 1, we will have to replace everyone, and minus 1, right? I thought that it will also take n time, but how is it constant? How is this summation assuming, then placing 1 1 1 minus 1 constant? Interesting. So, yeah, that this is true. It only takes constant time because we are doing it like whenever it counted zero, we are forgetting and then considering current number as my candidate and then doing it again. So so the 5 at index 5 will be next candidate. Yeah. So majority of that suffix we need to find. This is an interesting algorithm which I could not have come up if I was given infinite time. Okay everyone, thank you so much for watching. If any